Welcome to a brand new lesson focusing on equivalent fractions. Yesterday, we identified equivalent fractions and compared fractions using a fractions wall. This was a visual stimulus that made it really easy for us to see which fractions had equal values. Today, we're going to begin to focus more on the relationship between the numerators and the denominators of different fractions to identify whether they're equal or not. I'm going to begin today's lesson by asking the question, sort the fractions in the picture into two groups, and the two groups have to be made up of equivalent fractions. One way to do this is using the fraction wall. You can identify each of the fractions on the fraction wall, and then that makes it really easy to compare whether or not they're equivalent to each other. It's important, though, that we have to find other ways to do this and maybe use the relationship between the numerator and the denominators of fractions to be able to work out whether they're equivalent or not. Yesterday, from our fraction wall, we were able to identify that if a fraction is equivalent to 1/2, the denominator will always be double the numerator. Okay, let's think about that again. If the fraction is equivalent to 1/2, the denominator will be double the numerator. Well, look at half. The denominator is 2, which is double the numerator, 1. Do any of the other fractions satisfy that fact? We're looking for the denominator to be double the numerator. Did you identify those as equivalent halves? Let's see if we can prove that they are equivalent fractions pictorially. Okay, so what you can see in front of you is a rectangle, and it has been divided into two parts. So it's been divided to show halves. That's one of our fractions. Now we want to draw more rectangles and divide them into equal parts to show that 2/4, 4/8, and 5/10 are all in fact equivalent to a half. The rectangle has been split into 4 equal parts showing quarters. 2 of those parts are shaded, and you can easily see that it is equivalent to the half above. The same rectangle has now been divided into 8 equal parts. 4 of the parts have been shaded in, and you can see again it is equivalent to a half fraction. 4/8 and a half are the same value. Here is a visual representation to prove that a half, 2/4, 4/8, and 5/10 are all in fact equivalent, and we've done that by dividing up the rectangle. I'd like you to pause the video now, and I want you to do just what I did. I want you to draw a rectangle out and divide it up into the equal parts based on the denominator and shade in the numerators. And can you prove that those 4 fractions circled in pink are in fact equivalent? How did you get on? You can see from the visual representation there that I have divided up rectangles, and I've proven in a visual way that in fact all of those fractions are equivalent. They are all equivalent to 2/3. 2/3 is the same as 4/6, which is the same as 6/9, which indeed is the same as 8/12. They share the same value. Right, here we've got 3 equivalent fractions. 3/15 is the same value as 6, we don't know what, and that is the same value as a number of fifths, but there's a missing denominator and a missing numerator. we're going to use or examine the relationship between the numerators to begin with to work out what the missing denominator is in the second one. 3 and 6. What relationship is 6 to 3? Yeah, 3 times 2 results in 6. It's been multiplied by 2. If the numerator has been multiplied by 2, well then the denominator also has to be multiplied by 2. Here you can see 3 times 2 is 6, 15 times 2 is 30. And then you've got your rectangles, your visual representation down below to prove that they are equivalent. What about the last fraction? We're missing the numerator, but we know it's fifths. Well, we know that it's equivalent to 3/15. So we're going to have to examine the relationship between the two denominators. The denominators of 15 and 5. What's the relationship between 15 and 5? 15 has been divided by 3 to result in 5. So the denominator has been divided by 3, giving us a new denominator of 5. The rule is whatever operations carried out to the denominator, it must also be carried out to the numerator. So 3 divided by 3 leaves us with a numerator of 1. 3/15 is equivalent to 1/5. Right, guys, I'm going to ask you to pause the video now in a couple of minutes to give these 3 challenges a go. I want you to work out what digit is hidden beneath the splats. I want you to work out what are the equivalent fractions. Before you pause the video, just go back and think about the learning objective today. You need to examine the relationship between the 2 sets of numerators or between the 2 sets of denominators. And remember that golden rule of fractions. Whatever operation has been carried out to the numerator, it must be carried out to the denominator, or vice versa. And once you think you have worked out the equivalent fractions, if you want to be doubly certain, you can make a visual representation of your equivalent fractions using rectangles. Okay, pause the video now. Okay, for the first one, 1/4 is equivalent to 3, and we don't know. So what we've got to work on are the 2 numerators. We need to look at the relationship between the 2 numerators. What is the relationship between 1 and 3? Well, 3 is obviously 3 times bigger than 1, so it's been multiplied by 3. So now we need to multiply the denominator by 3. 4 times 3 is 12. So 1/4 is equivalent to 3/12. How'd you get on? If you didn't quite get that, pause the video now again and try and have a little look at your next 2. Just go back over it and see if you're in a better position to give them a go. Okay, so for the second one, we see that we actually don't have both numerators, so we're going to have to work off the relationship between the denominators. Well, the denominators are 5 and 20. What's the relationship between those 2 numbers? We can see that 5 times 4 is 20. So if the denominator has been multiplied by 4, we've got to do the same operation to the numerator. 3 times 4 is 12. So 3/5 is equivalent to 12/20. Okay, for the last one, again, we're missing a numerator. But we have got both denominators. So it's the same rule. We need to examine the relationship between the 2 denominators. What operation has been carried out to 16 to make it 8, to give us the new denominator of 8? Well, 8 is half of 16, so 16 has been divided by 2. If the denominator has been divided by 2, you know what we've got to do to the numerator. Yep, we got to divide it by 2. So 12 divided by 2 will give us a numerator of 6. Right, that brings today's lesson to a close.